So for number 3, you guys can see that denominators are not alike. We've got x squared plus 5x plus 6, x squared minus 4x minus 21. So we can't add these together because they're not like terms. So we need to look at each of the denominators separately, see what they are each kind of made up of, and then come up with the common denominator to use. So the first step is always just factoring. So we're going to factor what multiplies to get you 6, adds to get you 5. And once you factor it, you're really not concerned with what the original was, to be honest, guys. So once I factor it, I just kind of cross out the original. I'm concerned that it's really x plus 2 times x plus 3. And then your second fraction, what multiplies to get you negative 21, adds to get you negative 4, negative 7, and positive 3. So what would your common multiple of these denominators be, or what is the common denominator that we want to use that includes everything needed? So if we're looking at x plus 2, x plus 3, x minus 7, and x plus 3. So again, use everything that you see, but you only need the most that one of them has if one occurs more than once. So definitely need x plus 2. We need the x minus 7. And then, yes, there are 2 x plus 3s, but we only need one of them. So we need to figure out, okay, from the denominators we currently have, what is missing from the common one. So if we look at our first fraction, its denominator currently has x plus 2 and x plus 3. So from the common denominator, it's missing or needing the x minus 7. So we're going to put it in the bottom because we need to include it as part of the denominator. We just have to do it to the top and bottom. That's really equivalent to multiplying by 1. Changes the way it looks, doesn't change the value. So this is our common denominator, so that is perfect. Got that covered. We just need to figure out what 3 times x minus 7 is. So 3 times x, 3x, negative 7 times 3, minus 21. It's adding, so I'm going to bring down my subtractions or my addition sign. Okay, second problem. What is this guy missing from the common denominator? It's got the x minus 7, x plus 3. It needs x plus 2, top and bottom. So 2x times your x plus 2 gives you 2x squared plus 4x. And then we're just going to clean it up. So we keep that denominator, so I'll write it underneath here. So keep the denominator, all of its factors. You do not need to multiply it back together. It's just extra work that's not needed. But we are going to combine any like terms in the numerator. So this is the only x squared, so we'll just bring him down. But 3x plus 4x, 7x, minus your 21. So again, the goal is to go from 2 fractions to 1 fraction in your final answer. So if you're adding and subtracting, that just means you might have to create common denominators, so you'll have to multiply by what your fractions are missing to come up with that common denominator for both of them. So let's look at number 4. So factor the denominators, x squared minus 3x, GCF of x. Once you factor it, don't really care what the original is. Okay, x squared minus 4x plus 3, trinomial, quadratic, normal, what multiplies to get you 3 adds to get you negative 4, negative 3, and negative 1. Okay, so what is this common denominator that we need? Definitely need a single x, and then definitely need an x minus 1, and we need 1 x minus 3. Okay, so what is missing from the common denominator in the 2 denominators you currently have? So the first guy is missing x minus 1, so the top and bottom. by x minus 1. So since these are two binomials, you guys either need to set up a generic rectangle or do some foiling. So x minus 1 times x plus 2. So x squared, negative 1x, 2x, negative 2. So that will end up being x squared plus 1x minus 2. Bring down your subtraction sign. And then your second fraction, what is it missing from the common denominator? Just that x. So x times 2x minus 1. 2x squared minus 1x. All right, so we're going to combine like terms, keeping in mind that this minus is minusing that whole expression. So 1x squared minus 2x squared is negative 1x squared. 1x minus negative becomes plus. So 1 plus 1 plus 2x minus 2. Still over that common denominator of x times x minus 1, x minus 3. All right, I'm going to do one more with you guys. So for number 5, x over x minus 5 minus 2x plus 2 over x squared minus 4x minus 5. So can't really factor x minus 5 in this first fraction here. I'm going to sort of move this up a little bit. So it's just going to say, I'm actually just going to throw it in parentheses just so we know that it's like its own expression. X and negative 5 are not factors. Factors are things multiplied together. So if you've got things adding and subtracting, they need to stay as 1. So x minus 5 is just that fraction's denominator. So your second denominator, if you factor that, x minus 5 times x plus 1. So the common denominator needs to have an x minus 5 and an x plus 1. All right, so what are we missing from our current denominators to make it look like the common denominator? Well, the first one is missing x plus 1. So top and bottom times x plus 1. So x times x plus 1, x squared plus x. We're subtracting, so we're going to bring down the minus sign. Second fraction, what is it missing from the denominator to make it the common denominator? Actually, nothing. So if that already is what the common denominator has to be, we don't need to multiply 2x plus 2 with anything. We're just going to bring it down and combine what we can. So we've got the x squared, and then 1x minus 2x is negative 1x. Minus that 2, minus 2. Okay, so we've not talked about checking to make sure that we can't go further. So like if you got this far, this is great. We've got it to one fraction, wonderful, good. But you do want to check that you can't factor it further. So what I mean by that is like it's possible that your numerator, if you factor that, if it is factorable, one of its factors could be the same as the denominator, and then you would need to reduce it. So like if you tried to factor the top, what multiplies to get you negative 2, adds to get you negative 1, negative 2 plus 1. So if you factor that numerator, well, now that you're looking at those factors with your denominator, this here equals 1. They cancel each other out. So it's not reduced if you want to check that. So you don't you can't always simplify at the end, but it would be a step you want to do. Just check that what's left in your numerator can't be factored, and if it can, there might be a factor that reduces or is the same as what's in your denominator. So that would just be the very last step. Can you factor the numerator? Are any of them the same as the denominator? That would equal 1 to then cancel out. But really, factor your denominators and then come up with common denominator. Multiply by whatever is missing. But the goal is to go from 2 fractions to 1. It's just a matter of coming up with that common denominator from the 2 fractions that you currently have.